I want to show you a video. I'm not going to show you the whole video, but it's a video that I'm going to show probably every day when we start talking about all this stuff, because it connects and it gets stuck in your head, and music is a good thing to get stuck in your head. So let's see, where is it? Oh, here it is. All right. So the first part, yes, the first part of the video, you have to do a little reading while the music's going, and then the guy will start singing about certain things, and then it'll get stuck in your head. Let's watch.
Transforming that shape, there's a few options that are available to me, because I could rotate, turn it round, translate, shift it left, right, up or down, reflect, copy it across an axis of symmetry, rotate, turn it round, translate, shift it left, right, up or down, reflect, copy it across an axis of symmetry. Hey.
All right, so that's a little rotate, translate, reflect video. They don't talk about dilate in that video. I don't know why, but if you looked at the beginning, they talked about we do these things to polygons. Polygons are flat shapes with edges. A circle is not a polygon, and a cube is not a polygon. And so that's what we're doing right now. So rotate, everyone sing, turn it around, translate. No, nobody? Okay. All righty. So let's take out our notes. Now, if you go to Schoology and you log in, let me show you. And you go to our course, period 11. And you go to week 3. Now, I'm just going to, last semester, I did a week, and I had like 4 folders for the week. I'm just doing 1 folder per week now. So week 3 just has 1 folder. It says week 3 materials. Click on week 3 materials, and you'll see all the stuff. So if you look here, we have translations notes, which we're going to start taking right now. And we have translations homework. Now, I finally did it, guys. I finally did it. If you click on notes. Oh, wait. It's not showing up here. If you click on notes and you're in Google Chrome, for some reason I'm not in Google Chrome, it should say on the side of it, open with Kami. So you will be able to open your notes with Kami now. And you can write on the Kami. So you can save your notes that way if you want to do it that way. Okay. If you still want to use paper and pencil, which I recommend just doing it on paper. Or printing it out and doing it like that. If you can, remember, if you have a printer, print it out. Or if you have a friend, I've had some people say, hey, my friend printed it out for me, and they dropped it off in my mailbox so we can social distance. That's an option. But if you want to do it on Kami, you can now. You can click on the notes, and then it should say open with Kami on the side if you open it with Google Chrome. This is Safari, so I apologize. But it is there if you open it with Chrome. And the second thing I did is I separated the notes and the homework. Okay, some of you didn't like that I had the whole packet with everything together and it was hard to find stuff, so I just separated it now. Separate it. Okay, so your translations notes is just notes, and this translations homework is just your homework, and it's due tomorrow. Okay, again, your homework will have open with Kami on the side, and you can just do that. Okay, hopefully that makes it easier for you guys, because look, I'm telling you guys, I'm asking you guys to do things that are tough for you, right? Like trying in math, because some of you, that's very tough for you. And I'm here to help you, to try to make it easier for you. So I separated the notes and the homework. I made them both openable in Kami, so you can write on them if you want to do everything digital. Because if you open your notes and you write on it on Kami, you can save it in your Google Drive, and then next time you want to see your notes, you can go in there. Or if you're old school, which is nice. You can put in paper. So if the internet's out, your paper doesn't disappear, right? You still have your notes here. So all that good stuff. Any questions? So I'm going to be doing the notes. So if you want to click on I'll give you a minute to go to your translations notes and either print them out or open them up. Yes, I am. I'm recording right now. I actually should have muted you. You shouldn't have talked right now. I'm sorry. That was my fault. Because yes, I'm recording now. I'm going to put these I'm going to put these videos in the folder. Sorry, yes, I am going to mute you now. Thank you for reminding me though, because yes, I did start recording. And no, I'm not recording on Zoom. I'm recording on my other platform because it's a little clearer. I know the Zoom ones are kind of a little blurry sometimes. So hopefully this one's a little clearer. All right, so I'll give you a minute to get this out, to get your paper, to get your notebook, to get whatever you need. You should have had this out anyway because we do warm-ups, but it's okay if you didn't. But to get the notes out. Or some of you like, Mister, I don't get the notes out. I get them after because I just look at your screen and I just copy what's on your screen and I do it that way. And that's fine. That's fine. So I'll give you another 30 seconds to do that. Okay. All right. So what is a transformation? Okay. Just transformation in general. So this one's about translations, but what is a transformation? Okay. A transformation is an operation that maps. What do you mean maps, mister? Hold on. Let me go to here. What do you mean by maps? Well, let's see if we can find a context clue. A transformation is an operation that maps an original figure called the pre-image into a new figure called the image. So mapping means I'm just drawing coordinates, right? I'm just drawing coordinates. Right? So I'm mapping a pre-image into a new figure called the image. I'm just moving, right? Mapping can also be seen as moving a figure. We're just moving a figure by drawing the new coordinates. We have old coordinates and we're drawing new coordinates, so we're moving it. Now, there are 4 ways to move it. Okay? But we're going to first talk about one. Okay? So if you look at this graph over here, on the graph to the left, triangle ABC is the pre-image. So if you look here, triangle ABC is the pre-image. That means that's the first image. And then, if you look here, what happens? We still see it ABC in the new one, right? You still see ABC here, but you see a little apostrophe next to it, right? We call that A prime, B prime, and C prime. So now we have triangle A prime, B prime, C prime. Okay, so the pre-image is just the regular letters, and the image is the prime, A prime, B prime, C prime. It's the moved image, right? So that's the pre-image. That's the original. Okay, Mister, why don't they just say original? I know. You know how mathematicians are. They like to invent their own vocabulary. Hold on, someone's coming in. Let me take roll. Okay, so the pre-image is the original image. And then the image, what we call the image, is after it is moved. Okay. And then we put that little apostrophe after the letter. That little apostrophe means prime. We just say prime. A prime, B prime, C prime. So we know the one that says prime is the image that was moved. Right? It's after it was moved. Okay. Okay. Any questions? Any questions? Because this is brand new to some of you. And that's okay. If you're confused, let me know. So a transformation can change three things. It can change the position of an image, right? It can change where it is. It can change the orientation. What does that mean, mister? It can change the orientation, meaning, okay, I'll get to that right now. You can change the orientation, meaning, rotation and stuff like that. The orientation like this, if it's pointed up, if it's sideways. So orientation means like up, down, sideways, etc. Or it can change the size of a figure. Okay. Now someone's saying, Mister, it's difficult to draw the coordinate plane. Okay, I'll get to that in a second. I'll show you how you can do it a little simpler. If you're just doing it on paper, you're like, Mister, my paper doesn't have squares on it. It just has lines. How do I draw a coordinate plane? I'll show you. You can just draw like this. You don't have to draw all the squares. You can just draw little tick marks on the x-axis and little tick marks, and you can use the vertical lines to do the tick marks for the y-axis. So you can do something like this. If you can't see what I'm doing, let me. Right. So you can do little tick marks like this, right? Now, you can make it smaller if you want to, like right there. That's a little sloppier. I know my writing's a little sloppy. Or you can do larger tick marks just on the axis. So you don't have to draw all the squares. You can just do little tick marks so you know where things are. And then like if you want to graph a point, like if you look here, right, if you look here, like B is 3, 1. So you would do it like this, 3, 1. Kind of like this. That's B prime, right? Kind of like that. Oh, 3, 1, something like that. Okay, so if you can get a notebook that has graph paper, I had one of those composition books. It cost me like 80 cents. That's the one I used to show you. Before. Oh, it's over here. Forgot to move some of my stuff. So I got a little comp book that has graph paper in it. Right? Has graph paper in it. And this cost me like 80 cents. So if like, I think that was at the beginning of the year when things were on sale. You know how back to school sales. But I don't think it's more than $1 or $2. I think you can find it at Dollar Tree or 99-cent store, or even if you go to Office Depot or Target or Staples, they should be not much more than a buck or so. So that's a good option. But if you can't get that for some reason, or if you don't go to stores and stuff, like I don't, I order everything online. Doing it like this is fine. Doing it like this is fine. Okay, so everyone good on transformations? Transformations is an operation that maps or moves an original figure to a new figure. The original is called the preimage, and the new figure is called the image. Okay, so the original figure has regular letters A, B, C, D, E, F, G. The moved figure is called the image with little prime on it, A prime, B prime, C prime, D prime. Okay, and transformations move position, orientation, or size. Okay. All right. Mister, we haven't got to translations yet. I know. I'm just giving you an overview. So yes, I'll give you a minute. Someone's asking me, Mister, please give me some time to write. Can you be quiet too? Okay, I will. Okay, some of you are saying it's blurry. Does that help that I zoomed in? Orientation means like it's up or sideways or upside down. Orientation means, how it's oriented, right? How the position, like not the position, because position just means I'm over here and I'm over here. Orientation means I'm right side up, I'm sideways, I'm upside down. Okay, is that better? That I zoomed in like this? Because I know some of you said when I zoom out it's a little blurry. Let me know in the chat if it's still blurry. Position just means my position. I'm over here. Now I'm over here. Now I'm over here. But I'm keeping the same orientation, right? I'm not going sideways or anything. I'm just like if I'm here or I'm here or I'm here, right? Position. I'm moving left to right or moving up and down. Right? So orientation is, up, down, sideways. Position is just keeping the same orientation. I'm just moving left to right or up and down. Okay, are we good to move on? I told you orientation is sideways, upside down, right? Position is just where you are. Orientation is how you are, right? Am I sideways? Am I upside down? Right? I don't have to move position to move orientation. To move orientation, I can move upside down right now if I want. Like, look at my head sideways. I just move my orientation. Okay, look at my head. I move the position. Right? So they're just saying 3 things I can do to an image is I can move its position, I can move its orientation, or I can move how big or small it is. All right. Rigid motion. What is a rigid motion? Okay, there's some motions, if you think about it, that preserves the size and shape of the figure. So when I do something to a figure, it looks exactly the same. Like this little flashlight, right? I'm changing the orientation, right? But does the size and shape change? No. The size and shape stays the same. Now here's the same flashlight. I'm moving the position. Is the size and shape the same? Yes, they are. Yes, they are. So I am preserving the size and the shape. So that's a rigid motion. Now, what about if I made the flashlight larger or smaller? Larger, smaller. Now I'm changing the size of it. Not changing the shape, but I am changing the size of it. So that's not a rigid motion. So a rigid motion is when a transformation preserves or keeps. Right? Preserves means keeps the size and shape of a figure. So how do we say that in geometry? Okay, so we want to say geometrically, all, and this is the important part, all corresponding sides and angles of the preimage and image are congruent. Okay, so if I do a rigid motion, the preimage and the image are exactly the same. They're still congruent because the size and the shape didn't change. And what are some examples of rigid motions? Translations, which we're going to start learning today. Reflections. And rotations. Okay, those ones keep the same size and same shape. Okay, so that's what a rigid motion is. What do you mean, what am I doing? I'm explaining what a rigid motion is. A rigid motion means it's rigid. Because that's geometry, right? If I have a rigid motion, that means I'm just moving it. The size and shape doesn't change. So if the size and shape doesn't change, that means all the sides and all the angles are congruent. Right? If we look at this picture, I just moved this here, right? Yeah, I'll go back. But I'm answering your question. I'll go back. I just moved it. This is a rigid motion. That means the pre-image, the orange one, and the image, the pink one, are exactly the same. They're congruent. All the sides are the same. All the sides are congruent. All the angles are the same. All the angles are congruent. So that's all I'm saying here in a rigid motion. Is when I do a rigid motion, all the sides and angles are congruent. So the first sentence is the definition of rigid motion. And the second sentence is just telling you what does that mean in geometry? What does that mean for us geometrically? The stuff we've been learning. Well, both shapes are congruent. Put a thumbs up on your reactions when you're done copying this, so that way I know, because I can't see any of you and I have you all on mute. So please put a thumbs up when I finish copying this. Down in your reactions. Awesome. Thank you guys. If you're still working, that's fine. If you're still copying, that's fine. Okay, can I move on to the next thing? So these top two things are just transformations in general, but now we're going to talk about translations. And speaking of that, the title, my fault. The title should say transformations and then dash translations. So please change the title. That was my fault. Transformations is the big topic. but these notes are all about translation. So the first two things, we talk about transformations in general, what a rigid motion is, and then now we're going to talk about translation. That's the first one we're going to talk about. We're going to spend a couple days on that. But are there any questions on what a transformation is or what a rigid motion is or anything I wrote here? Any questions? Alrighty. So what is a translation? What is a translation? That's when someone speaks a certain language, mister, and then you translate it to another language. Okay, that is what a translation is, but that's not what a translation is here. Okay, so a translation, okay, the definition. So let's write right here. Definition is to vertically and or, because we can do both, horizontally slide a figure. Right? So sliding is another word for translation. So we're going to get a figure, a shape, and we're going to slide it either left or right, or up and down, or both, left and right, and then up and down. Okay, that's a slide. And it's a rigid motion, so that means the figure, the pre-image, and the image look exactly the same. What's an example? Right here. Right here, right? So if you look here, I have triangle A, B, C. That's the pre-image. And now I have triangle A prime, B prime, C prime. The same exact image, but it's slid over. Now, how did we slide it? Now we got to ask ourselves, how? What do you mean? I'm showing you an example. Right? To vertically and or horizontally slide a figure. Right? To vertically and horizontally slide a figure means I just get a figure and I slide it. So if you look here, I have the red triangle and I slide it to where the blue triangle is. And so how did I slide it? Well, let's look at each point. Let's look at point B. What happened to point B? It went 1, 2, 3, 4, 5, 6. It went 6 units forward and then 1, 2, 3 units down. Okay, so B went 6 units forwards, 3 units down. Let's look at C. 1, 2, 3, 4, 5, 6 units forward. And then 1, 2, 3, 3 units down. Did A do the same thing? 1, 2, 3, 4, 5, 6. And then 1, 2, 3. So each point went 6 units forward and 3 units down. So that's my slide. So you can even say that in words. The figure triangle ABC slid 6 units, you can say forward, or 6 units to the right, and 3 units down to get to figure A prime, B prime. Sorry, triangle A prime, B prime, C prime. Okay, so we just described the pre-image, which is the original image, ABC, slid 6 units forward and 3 units down to get to the new figure. Okay? Yes, I am sorry. It is 9:50. That means class is over. So we will continue this tomorrow. Homework is not due tonight. You do not have to do the homework. We will continue this tomorrow. Sorry, guys. We took it 9:50. Take care. I'll see you all tomorrow. Bye. Sorry.